we're going to find f of g of 2 right here. So just remember what that means. If you reread it this way, it's a lot easier to think about. F of g of h, I forgot left out the h, I think, when I said it the first time. F of g of h of 2. So what that means is I'm going to plug 2 into h, get my answer, my output, whatever my output, my answer is, goes into g, get my output, my answer, and that goes into f. So we'll start by plugging in 2 into h. So h of 2, so what? 2 squared is 4 times 3 is 12. 12 minus 3 is 12 minus 9 is 3. So I'm going to take 3 and plug it into g. So what is g of 3? 3 times 3 is 9, minus 6 is also 3. And now, so I got 3 back out again, I'm going to plug 3 into f. So plug 3 into f up there. Square root of 3 squared is 9 plus 1 is 10. I think we end up with the square root of 10. Should be my answer right there. Let's hurry and put that in there. Then we'll try the next one. So square root of 10. So there's my square root. Okay. Let's then go on. Next thing it says is to find what is g of h of f of x. And kind of dreaded news a little bit. It does tell us to simplify the result. So that means we got to take whatever answer we can get and simplify it down. Hopefully it isn't too bad. We'll see. So we're going to go g, let me grab the marker there, sorry. We're going to go g of h of f of x. So start with f of x. It's the square root of x squared plus 1. And let's plug it into h first. So we're going to come down to h. And where there's an x, we're going to replace it with the square root of x squared plus 1. So I'm doing this part. I'm doing the h of f of x. Okay, so take the, I'm going to go 3 times, in place of the x, plug in the square root. Okay, so that was the h of f of x. So simplify it. When I square a square root, that's kind of nice. They cancel out. So I end up with 3 times x squared plus 1 minus 9 times that 3 through. So we end up with 3x squared minus 6. Okay, that part was just the h of f of x. Now we got to take that part and plug it into g. So let's go to g, which is right here, right here. We got to plug that in. So it would be 3 times, put in the 3x squared minus 6, minus 6. Okay, distribute that 3 through, that'd be 9x squared minus 18 minus 6. Combine those together, so 9x squared minus 24. Let's put that in here. So 9x squared minus 24. Okay. Now, it wants us to use interval notation when writing the domain of the function g of h of x. So here's the tricky part, is we've got to start, right, when I plug a number in, it goes into f first. Right? So I've got to start by saying, what is the domain of f? Well, that's a little bit tricky. When you look at it, f has a square root. So we always said, right, that inside the x squared plus 1 has to be greater than or equal to 0. Well, guess what? It's always greater than or equal to 0, no matter what I put in for x. Because if I put a negative in here and square it, it's going to be a positive. And a positive plus 1 is never going to be less than 0. So I think anything works. When we plug it into f, anything works. Okay, now when I plug it in, now the next it has to take my result, my answer, and it has to go into h. So down here we got, for h of f of x, we've got 3x squared minus 6. Well, you can plug whatever number you want into there also, right? There's no fraction, there's no square root. And then look at our final result, the 9x squared minus 24 right there. Is there any restrictions on that one? And there isn't. So you've got to start from the inside. First, are there any restrictions on f of x? Second, are there any restrictions on h of f of x that we got right there? Third, are there any restrictions on the g of h of f of x, which is this one down here? And there's no restrictions on any of those, so our answer ought to just be negative infinity to infinity. Let's check it, see how we do. So we're going to do our interval notation. So parenthesis, negative infinity. Ooh, sorry, this is kind of a mess here. See if we can get it so we'll show this. Okay, negative infinity to infinity should be my answer. I bet you guys are so much more computer literate than me that I bet you can get these answers in a lot faster than I can. Okay, I think we got that in there, just negative infinity to infinity. Let's check it, and it looks good.